It had no taste, color, or smell, and we often look right through it. It covers over 60% of the Earth, cycling from the oceans and rivers to the clouds and back again. It even makes up about 60% of our body. With all of this water around and inside us, it's easy to take its presence for granted. But in the rest of the solar system, liquid water is almost impossible to find. So how did our planet end up with so much of this substance, and where did it come from? As you probably know, a water molecule consists of two basic parts. Hydrogen, the simplest of all elements, has been around since close to the beginning of our universe. Oxygen enters the scene several hundred million years later. Other stars began to form. The massive pressure at the center of the fiery inferno was so great that hydrogen atoms fused together to form helium. Helium in turn fused to form heavier elements like beryllium, carbon, and oxygen. The process known as nucleosynthesis. When stars eventually collapsed and exploded into supernovas, the new elements were spread across the universe and combined into new compounds like the now familiar H2O. These water molecules were present in the dusty clouds that form our solar system and more collided with our planet after its formation. But there are big questions that we don't have the answer to. How much water arises on Earth and when? If, as one theory goes, relatively small amounts of water were present on Earth when the rock formed, the high temperatures and lack of any surrounding atmosphere would have caused it to evaporate back into space. Water would have been unable to remain on the planet until hundreds of millions of years later, when our first atmosphere forms through a process called outgassing. This occurred when molten rock in the Earth's core released volcanic gases to the surface, create a layer that could then trap escaping water, and the water get back to the planet. Scientists had long suspected that most of it was brought by ice-bearing comets, or more likely asteroids that bombarded the Earth over millions of years. In examining carbon-natured chondrite meteorites that formed shortly after the birth of our solar system, scientists have found that not only did they contain water, but their mineral chemical composition matched rocks on Earth and samples from an asteroid that formed at the same time as our planet. This suggests that the Earth may have accumulated a substantial amount of water early on that were able to stay put despite the lack of an atmosphere. True asteroids may have burst more over the eon. If this turned out to be true, life may have formed much earlier than previously thought. So we do not yet definitively know whether the water on Earth came from its initial formation, later impacts, or just some combination of the two. Regardless, the water that runs from our shower, drinking fountain, and faucets is something that didn't just come from a nearby lake or river, but first underwent a comet or chaotic journey to get here.